We are all accustomed to thinking of solutions as mixtures of a substance dissolved in water. But in fact, the meaning of the term solution is broader than that. Perfumes, antiperspirants, the air we breathe, the alloys we come across in daily life like steel, brass and bronze are all solutions. The utility or importance of solution in life depends on their composition. Body fluids are examples of complex liquid solutions containing many different solutes like electrolytes, sugar, urea, oxygen and carbon dioxide. The importance of the concentration of solutions can be seen from the fact that any change in their concentration can have a significant impact on the living system. For example, 1 part per million or 1 ppm of fluoride ions in water prevent tooth decay, while a concentration of 1.5 ppm causes spotted tooth. And any concentration at and above 4 ppm becomes toxic. Therefore, sodium fluoride is used as rat poison. Intravenous injections are always dissolved in water containing salts at particular ionic concentrations, so as to match the blood plasma concentration. A solution is defined as a homogeneous mixture of two or more chemically non-reacting substances whose composition can be varied within certain limits. A homogeneous mixture is one in which the composition and properties are uniform throughout. In a solution, the component that is present in a smaller quantity is known as the solute or the dissolved substance. The component that is present in a larger quantity is known as the solvent or the dissolving substance. The solution has the same physical state as the solvent. A solution containing only one dissolved solute in a solvent is called a binary solution. Depending upon the physical state of the solvent, various types of solutions that can be formed are a solution in which a gas is the solvent, and a gas, a liquid, or a solid is the solute, is known as a gaseous solution. For example, air is an example of gas in gas type of solution. Chloroform mixed with nitrogen gas is an example of liquid in gas type of solution, while camphor in nitrogen gas is an example of solid in gas type of solution. A solution in which a liquid is the solvent and a gas, a liquid or a solid is the solute is called a liquid solution. Oxygen dissolved in water is an example of gas in liquid type of solution. Ethanol dissolved in water is an example of liquid in liquid type of solution, while glucose dissolved in water is an example of solid in liquid type of solution. These liquid solutions occupy a special place in chemistry, as most chemical reactions take place in solution phase. Similarly, a solution in which a solid is the solvent and a gas, a liquid, or a solid is the solute is called a solid solution. A solution of hydrogen in palladium is an example of gas in solid type of solution. An amalgam of mercury with sodium is an example of liquid and solid type of solution, while copper dissolved in gold is an example of solid in solid type of solution. Out of the various types of solutions we just discussed, the most significant are those that are in the liquid phase. We will therefore confine our study to binary liquid solutions. The concentration of a solution is defined as the amount of solute present in a known amount of solvent or solution. Concentration can be expressed qualitatively as well as quantitatively. Qualitatively, we describe a solution as either dilute or concentrated. When a solution contains a small proportion of solute relative to the solvent, we call it a dilute solution. On the other hand, a concentrated solution contains a large proportion of solute relative to the solvent. This qualitative means of describing concentration, although useful, sometimes leads to confusion, and thus arose the need for a quantitative description of solutions. Quantitatively, the concentration of a solution can be described in several ways. These methods are mass percentage, volume percentage, mass by volume percentage, parts per million, mole fraction, molarity, molality. Let's discuss these methods one by one. Let us first discuss the mass percentage or weight by weight percent method. The mass percentage of a component of a solution is defined as the mass of the component in the solution divided by the total mass of the solution multiplied by 100. It is important to note that as we are expressing the concentration in percentage, it implies that we are defining it per 100 units of the solution. If X grams of component A is dissolved in Y grams of component B, then the mass percentage of A is given by X, which is the mass of A divided by X plus Y, which is the total mass of the solution multiplied by 100. For example, a 20% weight by weight solution of sodium chloride in water means that 20 grams of sodium chloride is present in 100 grams of the solution. Note here that 80 grams of water and 20 grams of sodium chloride make 100 grams of the solution. Another way of expressing concentration in percent is volume percentage or volume by volume percent. The volume percentage of a component in a solution is defined as the volume of the component divided by the total volume of the solution multiplied by 100. The concentration of solutions, where both the solute and the solvent are liquids, is commonly expressed using this method. For example, 25% of ethanol solution in water means 25 milliliter of ethanol is dissolved in 75 milliliter of water, such that the total volume of the solution is 100 ml. Yet another way of expressing concentration in percent is mass by volume percentage. This is expressed as the mass of the solute divided by the total volume of the solution multiplied by 100. For example, a solution of 23% weight by volume contains 23 grams of solute per 100 milliliters of the solution. This way of expressing concentration is widely used in medicine and pharmacy. When a solute present in a solution is in a very small quantity or trace amounts, then its concentration is expressed in another quantity known as parts per million or ppm. Parts per million or ppm is defined as the ratio of parts of the solute to million parts of the solution. Mathematically, It is expressed as the total parts of the component divided by the total number of parts of all the components of the solution multiplied by 10 to the power 6. The concentration can be expressed as mass to mass, volume to volume, or mass to volume. For example, the concentration of dissolved oxygen in seawater is 5.